Welcome back to Through Inquisitive Kids. This video is our introduction to rotation, another transformation on the geometric plane. We've already gone through 3 lessons, all talking about translations. Our learning goals for today is to master the concepts and basic properties of rotation and be able to solve problems with basic properties of rotation. So I want you to observe these images. What do they all have in common? Here, for example, we have a spinning wheel. We have gears, it looks like inside a machine. We have a fan. We have a Ferris wheel. And we also have this clock. What do they all have in common? What they all had in common was that some part of them was always rotating. And that's what we're going to talk about in this lesson. What is special about the following movement? Here we have a kid on the swings. And it looks like she's swinging from point A to point B. And she's swinging back and forth. And you can call that a rotation. Even though she's not swinging all the way around the center, which is O, she's still staying the same distance from O, except at another point. If you think about it, it's like A and B are both points on a bigger circle. And she's moving along the edge of that circle. From 12 o'clock to 4 o'clock, the hands on the clock rotated blank degrees, while it rotated 120 degrees. If this is 12 o'clock, 1, 2, 3, 4, and this is 4 o'clock. We're trying to find what is the angle here. And this looks like it's 1/3 of the entire circle. And the entire circle is 360 degrees. That times 1/3 equals 120. How can we describe this transformation? So we can think of these as blades. Blades are on a plane and they rotate at a certain angle around the center of rotation. This is the center of rotation. Each blade of the windmill rotates to a new position under the blowing of the wind. On a plane, turning the figure around a fixed point by an angle in a certain direction is called rotation. The middle is our center of rotation, and this angle is the rotation angle. In this case, P and P prime are both corresponding points. And the fixed point in the middle is the center of rotation. The angle is called the rotation angle. And if point P is rotated to point P prime, then these 2 points are corresponding. And the direction of the rotation can be either clockwise or counterclockwise. I suggest you really master what direction these are talking about, because when I was learning rotations, I was really confused between clockwise and counterclockwise. And you will hear these words very often in these problems. Here's some practice. Triangle ABD is rotated to get triangle ACE. What is the center of rotation? How many degrees is the rotation? Is it clockwise or counterclockwise? If M is the midpoint of AB, where does point M go? Here, if you can't see, there's actually an angle. The center of rotation would be point A, and the angle of the rotation is 60 degrees. And just so you know, it's counterclockwise. This is counterclockwise. This is clockwise. Point M was rotated to the midpoint of AC. If blade A rotates clockwise about O to blade B, the center of rotation is blank. Blank is the rotation angle, and it is blank degrees. The pairs of corresponding points are blank, 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 and blank. So in this case, the center of rotation would be O. We can think of this point as O. And in this case, the transformation is being from A to B. AOB would be the rotation angle, and it would be 60 degrees. We can find that by doing 360 divided by the total number of angles here, which is 6. That gives us 60 degrees. The pairs of corresponding points are A and B, B and C, C and D, D and E, E and F, and finally F and A. Conclusion. So in rotation, we have the center of rotation, the rotation angle, and the rotation direction. The rotation is on a plane, and the three elements listed above are essential to making a full rotation. Rotation is also a rigid transformation, which means that the resulting figure is congruent to the original figure. As shown in the figure, points A, B, C, and D are all on a grid. If triangle AOB rotates counterclockwise about point O to get triangle COD, the rotation angle is blank. So OB and OD are corresponding sides. Angle BOD is the rotation angle. Therefore, the rotation angle is 90 degrees. First, you have to see what sides are corresponding. We can find OD and OB. Now you just have to find how much they each individually rotated. You don't have to look at the entire figure, just these two corresponding sides. You can see that they rotated 90 degrees, which means that the entire figure rotated 90 degrees. Our answer is C. Here we have angle AOA prime. So it's this red angle, OA prime. And that equals angle BOB prime, the green angle, which equals the blue angle also. And CO is equal to C prime O. And the line segments are also the same. AO and its corresponding point connected to O is the same. BO and the distance from its corresponding point to O is also the same, and same for C. We can conclude that when you connect corresponding points to O, the angle formed by each pair of corresponding points are equal. Every point on this figure rotated the same amount of degrees. And the reason why AO is equal to OA prime is because they always stay the same distance away from O. You can imagine them as on the outer circumference of a big circle. The distance from corresponding points to the center of rotation is equal. See, look, they're all equal. The rotation angle is formed by the line connecting any set of corresponding points in the center of rotation. So you can first find a pair of corresponding points and then connect those both to the center of rotation. The center of rotation is the only fixed point during the transformation, and the corresponding line segments are equal, and the corresponding angles are also equal. Point E is a point in square ABCD. Rotate triangle ABE clockwise about B by 90 degrees to get triangle CBE prime. If AE equals 1, BE equals 2, CE equals 3, then angle BE prime C equals blank degrees. In this case, you had to add auxiliary lines to help you out. We first connect E and E prime. According to the properties of rotation we just learned, BE equals BE prime. So BE equals BE prime. Angle BE prime E equals 45 degrees. 45 degrees. And using the Pythagorean theorem, we can find that E prime equals to the arithmetic square root of 2. So then according to the inverse of the Pythagorean theorem, angle E prime C would equal 90 degrees. Therefore, angle BE prime C, the angle we're trying to find, equals 135 degrees. Isosceles triangle ABC is rotated counterclockwise about B by alpha degrees to the position of triangle A1, C1. AB and A1C1 intersect at point D. AC intersects with A1C1 and BC1 at points E and F respectively. Prove triangle BCF is congruent to triangle BA1D. According to the properties of isosceles triangles, AB equals BC, angle A equals angle C, and according to the properties of rotation, A1B equals AB equals BC, angle A1 equals angle A, which equals angle C. Angle A1BD, A1BD is equal to CBC1. CBC1. According to the properties of congruent triangles, triangle BCF is congruent to triangle BA1D. Here's another derivation process. Because triangle ABC is an isosceles triangle, AB would equal BC and angle A would equal angle C. According to the properties of rotation, A1B equals AB equals BC, angle A equals angle A1, which equals angle C, and angle A1BD equals angle CBC1. And in triangle BCF and triangle BA1D, we can conclude these three statements. Therefore, these two triangles, BCF and BA1D, are congruent according to the angle side angle theorem. Expand your thinking. Rotate a right triangular ruler clockwise around the vertex by 30 degrees so that AC and the resulting hypotenuse are in the line. What is a rotation angle? What are the characteristics of triangle ABB prime? ABB prime. The rotation angle would be 150 degrees. And you can see that triangle ABB prime is actually an isosceles triangle. That's because AB is equal to the length of AB prime. Class summary. Today we learned about rotation. We learned what its definition was. It has 3 key points: the center of rotation, the rotation direction, and the rotation angle. And we learned that the figure is congruent after rotation because this is a rigid transformation, and the distance from corresponding points to the center of rotation are equal. I hope you learned something from this video, and be sure to come back for our next lesson on rotation.